Okay, this video is all about geometric mean, and so we'll be covering 3 things before we go through the 2 handouts that were assigned for practice. So writing similarity statements, because that's one part of the Math Excel, altitude and leg rules, and then using proportions to solve. So 2 and 3 are 2 different ways you can solve geometric mean problems. We'll go through the same 4 problems, solving it using the altitude and leg rules, and solving it using the proportions. So first, writing similarity statements, that's the first of the 3. So when you create an altitude in a right triangle, there are 3 similar triangles that are created. Similar triangles mean they have the same angles, but not necessarily the same size, but they have the same proportions. So what I do to help me to understand which angles are the same are to draw in these little angle bends. So I put 1 in A and 2 in C. Now it doesn't matter if I put 2 in C or if I had put 2 in A and then 1 in C. As long as these have different amounts of angle bends, that way I can distinguish on the big triangle, as you can see there, which 2 angles are different. So I need to have 2 different markings for the 3 different angles in the triangle. Okay, then I'm going to start with, in our notes we did 1 to 90 to 2, but that's not always what you have to do. You can do it anyway. So I can start with the 2 angle marks and then go to the 1 and then go to the 90. So I'll do that just to make it different than what we did in the notes. So I'll name the first, and I want to start with the big triangle because that's the one I put the markings in first. So it's easiest to start with the big triangle. So I would do CAD, and again that's arbitrary. You can pick any way to start. That starting point, the first triangle can't be wrong. The second and third triangle have to match the order of the first. So if I name the middle triangle second, then right now the middle triangle has a 90-degree angle and it has a 2 mark. What it's missing is this 1 mark. And notice the 90-degree, I'm going to erase it for a second just so that you can see that it's not 90 degrees on the middle triangle. So because the 90 degrees continues going past this line, then we don't have anything on this angle. So we need a 1 angle mark here. And then on the other triangle, this is 90, B is 90, so that means that there's going to be a 90-degree angle here. And then we have a 1 angle mark and a 90, so we're missing a 2 angle mark. Okay. Now I'm going to add my 90 back because that does go with the big triangle, so it is significant in this triangle's name. So when we named the CAD, again, we went from the 2 angle mark to the 1 angle mark to the 90 degrees. So we need to be consistent for the other 2 triangles. I've already labeled all the angles, so I just need to look for a triangle to do second. I can pick the medium triangle or the small one, doesn't matter. So I'll just pick the medium one randomly. And I want to start with the 2 angle mark and then go to the 1 and then the 90. So I would start with C, then go to D, and then B would be my last. So C, D, B. And that's 2 to the 1 to the 90 degrees. And then on the last one, same thing. I want to start with the 2 angle mark, go to the 1, end at the 90. So I want to start with D because that has 2 bends in it. Then go to A and end at B. D, A, B. Okay, so that is my similarity statement for this problem. Again, no wrong way to start. The other 2 just have to match. Okay, one more example with that. Again, I'm just going to pop my phone is, I'm going to turn it on silent. I'm just going to pop my 90-degree angle, my 90-degree angle box here, and my corner. So I'm just going to put a 2 here and a 1 here. Again, arbitrary. I could put the 1 here, the 2 here. Doesn't matter. Now on this triangle, I have a 90-degree angle because that's where this meets, so they're both 90. And remember, these 2 form a linear pair. So together they make a straight line, straight angle EGH, which means if this is 90, then this is 180 minus that, which is 90. That's how come this one's 90. Okay, so I have a 2 angle mark and a 90 degrees, so I'm missing a 1 angle bend here. And I have a 1 angle bend and a 90, so I'm missing a 2 angle bend here. Okay, so now I can name the triangles, and I'm going to pick to go 90, 1, 2 this time. And I can start with any triangle, but I always start with the big one, so that's way it's easier If everyone starts with the big one, it's easier for me to check the work. Actually, it's not too bad either way. If you labeled your paper, then it's not hard in either way for me to check it. Okay, so starting with the 90 degree on the big outside triangle, I have F. Then going to the one I marked with one bend is H, and then E. So on the other two triangles, I want to start with the 90, so I can do G. And then I want to go to the one angle bend next, which is F, and then E. And then on the last one, starting with the 90s, G, going to the one angle bend, H, and then F. This is just one way that I use to do it. Other people do it differently, or they can just see long leg, short leg, whatever. But this is just a quick way to be able to tell if you put the little angle bends in there. So that would be the answer for the similarity statement for that. If you're doing this on Math Excel and you're trying to find a similarity statement that already works, what you want to check is to make sure once you go ahead and draw the triangle and label it, that all the first letters are the right angles. So for instance, F on the big triangle is the 90 degree angle. G on both of the other ones is the 90 degree angle, so that checks out. H is the one angle bend, so I need all the middle letters to be one angle bends. F is a one angle bend for this angle, so that works out. And then H is another one angle bend. And then same thing with the two angle bend, I need it to be E and then F one time, so two E's and an F. Okay, so you're just making sure that the angles are in the right order. Second topic is altitude rule and leg rule. So the altitude rule simply is the square root of the two parts of the hypotenuse multiplied together. So in this problem, my altitude is y because it's the one that connects the vertex of the right angle to the hypotenuse, so it creates an altitude if I turn my paper so that this is the ground. This would be the height of the triangle. So I can use the altitude rule for y, so y is equal just to the geometric mean between these two pieces. 5 times 9. Okay, 9 is the perfect square of 3, so this would be 3 radical 5. Or you can get the decimal answer, but I'm just going to do the square roots because that's what Math Excel wants. And your test. So on x, actually the test I do believe it asks for to the nearest tenth. So let's just go ahead and calculate this. So 3 times the square root of 5 is 6.7 to the nearest tenth. So either of those answers is acceptable. Okay, x is a leg, so I'd have to use the leg rule to do x. And the leg rule is to use the closest hypotenuse segment to that, so 5. And then you do need to figure out what the whole hypotenuse is going to be. This is a common error. A lot of people will multiply these, but the whole hypotenuse means if you started walking from here to here, you've gone 5 units. And then you pick up and go 9 more units, then you've gone a total of 14 units, so you just add them and you don't multiply. You multiply only in the actual equation, but not to get the hypotenuse length. So we use for x, we use 5 and 14 because that's the piece that's closest to x and the whole hypotenuse. Okay, 14 has factors of 7 and 2, and that's really it. And none of those are 5 or 2, or 5, so that means that this can't be simplified. So if we just multiply them back together, 14 times 5 is 70. So that's as simplified as the radical goes. And then if we just do the decimal answer, we get 8.4. Okay, and then for z, z is a leg closest to this hypotenuse segment. So for z, we would use the closest piece, so 9, and the whole thing. Oops, forgot my radical. 9 is a perfect square, so I can make this 3 radical 14. Or I could actually evaluate that in my calculator, so 14 radical times 3, or 3 times radical 14. Because it's multiplication, the order doesn't matter. 11.2. Okay. Second problem, altitude rule. So this one, if I tried to do x first using the altitude rule, I'm missing the 2 segments I need. So I could do this problem using the leg rule. To do that, To do that, I'm going to first do the leg rule and then call this variable like y, something other than x, because x has a particular answer for this problem, so I need to give this segment a different name than x. Okay, so when I do that, my leg rule, I'll use the 11 because that's the segment, that's the leg closest to this segment. So the leg rule for this particular problem would be the leg, which is 11, equals the square root of the closest hypotenuse segment, which is y, because remember the hypotenuse is the long side of the right triangle, so the 14 or the 61. So the closest hypotenuse segment is y, and the whole hypotenuse is 61. Okay, then I can solve that for y. So squaring both sides to get rid of the radical gives me 121 equals the radical and the square root cancel here, so we just have 61y. So 121 divided by 61 equals 1.98. I'm going to round it to the 10th because, the 100th, because I'm not done with my problem, so I want to as exact answer as I can get. So actually, ideally, if I can leave this in my calculator, that's the best. I won't be able to do that in this case because I need to subtract 61 minus 1.98. Well, 61 minus 2 would be 59, and then I just have to add 0.02. So 59.02 is going to be this last part. Again, that's just because the whole hypotenuse is 61. So if I subtract 61 here, it's going to give me a negative because I didn't put the 1.98 second. It should be 61 minus that, but I just take the absolute value of this. So 59.02 is this side. So once you get y, you basically just need to do subtraction to find the last hypotenuse segment piece. And now you can do the leg rule. The altitude rule, I'm sorry. So this was the leg rule. For the altitude rule, we can now do x equals the geometric mean between these two pieces. 1.98 times 59.02. So I'm going to make this positive, times it by 1.98. It was 3, so I'll leave it that. And equals square rooted. So x is about 10.8. So that's how you can use the leg and altitude rule to solve this kind of problem if you prefer those rules versus doing the proportions. So you can solve these problems either way. All right, moving on, 2 more examples with the altitude and leg rule, and then we'll do all 4 of these same problems using the proportions. Okay, leg rule for this, if we're trying to find x. X is a leg. Remember, you have to go back to the notes if you're confused about which sides are legs or altitudes. The notes has it explicitly written. So the legs are the 2 shorter sides of the big triangle. So these 2 sides. And the hypotenuse, of course, is the one across from the 90 on the big triangle. And then the altitude is the segment connecting those. So the leg is going to be equal to, the leg rule is going to be the leg equals the square root of the part that's closest to it times this whole hypotenuse. So I'm not going to put the 11 on the paper just so that you know that that wasn't going to be given to you. You do have to add those together. So I'll put it as 4 plus 7 in here so you know that's where I got the 11. Okay, so it's going to be 4 times 11, which the square root of 4 is 2, so it's 2 radical 11. Or I could change it to a decimal and make it 6.6. Okay, and I have to do twice more for these other 2 sides. Well, the leg rule once more and the altitude rule. So z is equal to the geometric mean between 7 and 11, both of which are prime, so it's 77, or 8.8. Okay, and then for the altitude rule for this one, we have y as the altitude. It is equal to the 2 pieces of the hypotenuse multiplied together. 4 is a perfect square, so we can make that 2, radical 7. or 5.3. Last one with the altitude and leg rule, and then we'll do all of the 4 problems with the proportions just to make sure you understand. Okay, so for this one, I put some different things in here. So this time you don't have, if you try to do the leg rule for z, you're missing z and x, which you need. If you try to do the altitude rule, you're missing x and y, so you have 2 unknowns. But we could do the leg rule using the 10. Okay, so if we do the leg rule, starting with the 10, because that has the most information, we only would have 1 unknown, which is x, plus 8 essentially. So the leg is equal to, so 10 is the leg. It's equal to the geometric mean between the piece of the hypotenuse closest to it times the whole hypotenuse. So to represent the whole hypotenuse, if I don't know one of the pieces, I have to call it x plus 8. Okay. Then I need to solve for x. So I square both sides and get 100 equals, again, the radical just falls off, and I have 8 plus 8 times x plus 8. So here we would do the distributive property. And solve for x. So we subtract 64 from both sides, so we get 36 equals 8x. 32 is divisible by 8, so 8 is going to be a decimal. So 36 divided by 8 is going to be 0.5, so 4.5. Okay, so x is 4.5. Now that we have x, we can use the leg rule for z, or the altitude rule for y. Okay, so the leg rule for z would be the leg is equal to the geometric mean between the part of the leg, the part of the hypotenuse closest to it, and the whole hypotenuse. 4.5 plus 8 would be the whole hypotenuse, so 12.5. When you get a decimal as the radical, so if I write this out, then you don't have to do the simplifying radicals. With the decimals, you can just get the decimal answer. So 7.5, you take the square root of that. Okay, because it's too hard to know what the factors of a fraction or of a decimal are. So they never make you do it that way. Okay, and the altitude rule for the final side, which is y. Y is equal to the geometric mean between the 2 pieces of the hypotenuse, so 4.5 and 8, multiplied together. We did that. 4.5 times 8 is 36. So the square root of 36, which would be 6. Okay, and you wouldn't put the square root of 36, you would just put 6, because it's a whole number. Okay, those were all the altitude ones. And now we're going to do the proportions. Okay, sometimes your triangle isn't drawn to scale. So I did this one where it's not drawn to scale. Just so you can see that you're going to have to use a little bit of logic for the proportions if it's not drawn to scale. Or you can consider the short leg, long leg, basically for the scale that's on there, which leg is short leg, which leg is long leg. So for this problem, if we're trying to find x, first of all, if we look, what we want to do when we're doing proportions is look for a triangle that has the most information about it. So if I do that, the big triangle, I only know the hypotenuse. The little triangle, I only know one side, and then the medium triangle, I only know one side, which means I'm going to be repeating some of the same variables. So when I do this, I'm going to do my proportion for all the triangles. So these problems are definitely easier to do with the leg rule and the altitude rule. It's the ones where it's not where they give you a triangle with at least two things. So like the middle-sized triangle on this one has two sides. Then it may be easier to do a different rule. Okay. So again, we're going to do for the big triangle, I'm going to identify the short leg, long leg, and hypotenuse. So I'm going to go off of the picture and not off of the numbers here to identify the short leg. So the shorter of the two that I've drawn is Z. So Z is the short leg on the big triangle on the outside one. The long leg would be X, and the hypotenuse would be the combination of these, so 11. Okay, then on the middle triangle, the medium-sized one, this one, my short leg, the shorter, I'm going to go again off the one that looks shorter, that's attached to the 90 degrees. So these are my two legs. The one that looks shorter is Y. The one that looks longer is 4. So this is why this part gets a little bit confusing, because sometimes the longer leg doesn't look longer. That's just because they didn't draw this to scale. But if you use a scale of the actual triangle drawn on the sheet, then you can get the right answer. Okay, and the hypotenuse of this triangle is X. And then we have to do the small triangle too. So on the small triangle, the short leg, the smallest leg is 7. The longer leg is Y. And the hypotenuse is Z. Okay, so we want to be able to find a proportion where we eliminate one row and one column, and we have only one unknown. Okay, so I'll say that again. So you're going to look for a proportion where you can eliminate one row and one column, and you only have one unknown. So if I try to do that here, I have 3 unknowns. I don't know Y, X, or Z, so I wouldn't use that. I have double Y's here, so I would try to eliminate the big and the hypotenuse. And now I only have one unknown. Y is the only thing that I don't know. So my proportion would be Y over 4 equals 7 over Y. Y over 4 equals 7 over Y. When I cross multiply this, I get Y squared equals the square root of 4 times 7. I purposely left it separate so that I could do the square root of 4, which is 2 radical 7. And we already got Y, so we just want to check to make sure that was the correct answer. And that's what we got when we did it the other method using the altitude rule. Okay. So you get the same thing, doesn't matter which rule you use. And now we want to look for a different variable. So let's see if we find X. X is repeated here and here, so 11 and 4 are going to be what goes with the X. So it's going to be X is to 11 as 4 is to X. When we cross multiply that, we get 4 times 11. Square rooting both sides, we get 2 radical 11 for X, which is what we previously got. And lastly for Z, Z is a little bit further stretched out, so that means you're going to be eliminating some middle segments, some middle columns. So I'm going to eliminate the middle column, and I'm going to eliminate this middle column. So now I can only see Z's. Z over 11 equals 7 over Z. That's my last proportion. Z over 11 equals 7 over Z. And when I cross multiply this, I get 77, which is what I got before. So Z is equal to the square root of 77. Okay, so same answers, no matter which way we did it. Okay, if we do the bottom one, just because this is the same thing, we'll set up again the big median and have a little more space this time, which is nice. So for the bottom triangle, I've got big, medium, small. Short leg, long leg, hypotenuse. Again, I want to go off of what it looks like. So I would go off of the shorter out of these two legs looks like Z on the big triangle. X is longer, and the hypotenuse is 14. On the medium-sized triangle, the shorter of the two legs, it looks like Y. 5 is the long leg, and the hypotenuse, which is across from 90, is x. And the last one, if I go the short leg, the small triangle. If I'm not sure, so these are pretty close. It looks like it could almost be isosceles the way that I've drawn it here. But I already have y as the middle triangle short leg. So then I know that y should actually be slightly longer than the 9. And z is the hypotenuse. So it doesn't actually matter if you mess these two up, as long as you don't have the y's in this y can't be the short leg on this triangle and the short leg on this triangle. It's going to reverse. Okay, and then we're going to do our column switching, our column canceling, and find x first. So there's two x's. So x is going to be the geometric mean between 5 and 14. So we get x squared equals 70, which doesn't have a perfect square, so it's just going to be 70. Then we do y next, so I will cancel these, and it's 5 and 9, which is 3 radical 5. And z is 14 and 9. Okay, notice I skipped writing the proportion because you're just going to be multiplying. If the two numbers are opposite each other, I mean the two letters are opposite each other, you're just going to be multiplying and taking the square root, so I just jumped to it. Okay, save some time. Because this video is getting pretty lengthy and I haven't even gotten to the worksheets. Okay, so the next one is, okay, so on this one, on the medium-sized triangle, I have two sides. So I'm going to use the medium triangle. And then on the big triangle, I have one side. So I'm going to try to use the big triangle and see if I can figure this out. Okay, so on the medium triangle, I have short leg, long leg, and the hypotenuse. Well, I have short leg, long. I have two of the sides, but I have y for the other one. So the shorter leg looks like y. This is my 90. The longer leg looks like 8, and the hypotenuse would be across from the 90, so I know for sure that that's 10. Okay, on the bigger triangle, the shorter leg looks like z, and the longer leg 10, and the hypotenuse x plus 8. Okay. So if I'm trying to solve for a variable, I'm going to need to cancel out the top row. I don't need to cancel out two rows because I didn't even draw the short leg one. I just need to cancel out the top row. And then that gives me, let's see, 8 over 10 equals 10 over x plus 8. 8 over 10 equals 10 over x plus 8. So when I cross multiply this, I get 100 equals 8 times x plus 8, which we've already solved that problem, but in case you skipped to this part of the video, I guess I can resolve it. Just ran out of space, kind of. So when I distribute, I get 8x plus 64 equals 100. Subtracting 64 from both sides gives me 36. I got my sister's text me. Okay, and I'm just going to see if I can pause this. Okay, and hopefully I'm back. Let's see, it's still, yeah, it's still taking. Okay, so 36 was 8x, and then dividing both sides by 8, x is 4.5. Okay, so this side is 4.5. At this point, I would definitely use the leg rule. And the reason why is because either I need to add the small triangle, which I don't even have any space to do. But if I try to do my proportion with, let's say, these two sides, I have still two unknowns. Or if I tried to do it with these two sides, I still have two unknowns. Okay, so I would need to add the small triangle here, which is a little tedious, but you could do, at this point you can do the leg rules, which will save you some time. I'm trying to think if I want to do the short leg. Yeah, I'll just add a sheet of paper kind of at the side here so you can kind of see it. So, if I do the small triangle, because I want to be thorough in case you're doing the proportion way. So the small triangle with a short leg, on the smallest triangle, the shortest leg looks like 4.5. We already found it, so we don't need to write x. The longer leg is y, and the hypotenuse is z. Okay, so when I set up my proportion, and actually on the hypotenuse on the big triangle, I can change it now to 12. I can make it 12.5 because I actually know the hypotenuse. So if I do, ignore that column and ignore this column, I have z is to 12.5 as 4.5 is to z. That's my proportion. Z is to 12.5 as 4.5 is to z. When you cross multiply that, we did that. So 4.5 times 12 gives you the square root of 56.25, which comes out to 7.5. And to find y, I would cancel out the big triangle and the hypotenuse. So I would use these. 4.5 and 8 are going to be what multiply together. So y is going to be the geometric mean between 8 and 4.5. Which we did that one. It was 36 square rooted, so that's 6. Okay. So that's the way to do this problem using the proportions. And we have one more to do using the proportions. So the last one, I don't need this paper anymore. The last one is the quickest out of all of them because we're only looking for one side. Okay, so this is, on the big triangle, we actually know three things. So we want to compare the big triangle to something else. It doesn't even matter what else because we have so much information from the big triangle. Short leg, long leg, hypotenuse. So on the big triangle, the short leg is 11. The long leg is 60. And the hypotenuse is 61. Then I can just use the medium triangle. Okay, on the medium triangle, this is the shorter leg. So x is the short leg. And the 60 is the hypotenuse. So I'm going to be ignoring the small triangle, which I didn't even write, and the long leg. So my proportion just would be 11 is to 61 as x is to 60. Okay, 60 times 11 equals 61x equals 660 divided by 61. Oh man, divided by 6. Oops. It's like 10.8. Okay. Those are all of the different methods you can use. I'm going to pause. I'm going to do the other stuff in a different video, so we won't do the worksheets on this video, so it's not super long. So again, this video will just cover these three things. Hope that helped.